Hello everyone, I welcome you all to the lecture 15 of this course, Construction Methods and Equipment Management. So in this series of lecture on the earth moving equipment, today we are going to discuss about the trucks. So in the last lecture, we discussed about the fixed position excavators, that is front shovels and the backhoes. Okay. So let us look into the outline of today's presentation. In today's presentation, we will be discussing about the types of trucks, and we will define what is the production cycle of the truck, what are all the components of the production cycle. Let us see how to estimate the productivity of trucks, and we will work out some problems on how to balance the interdependent missions. So as you know that the trucks and the loaders are going to work together, how to balance the size of the machines and how to balance the number of trucks for the loader. Okay. So we will work out some examples in this regard. So basically, for any earth moving equipment, we are more concerned about the economic haul distance of the equipment. So as you know that different equipment have their own economic haul distance. So in the earlier lectures, I have discussed that the bulldozer has an economic haul distance up to 100 meter, and your loaders, say crawler mounted loaders, will have an economic haul distance of less than 100 meters. So but your scraper has a better economic haul distance, say it is good in loading as well as in hauling. So it can have a haul distance up to 1000 meters. But for haul distance greater than 1000 meter, we are supposed to select the truck. So truck and wagons are the most common of the construction hauling equipment. So they are the commonly used hauling equipment. So what is this wagon? Wagon are nothing but earth moving trailers which are pulled by tractors. So let us now look into the classification of trucks. So in different contexts we can have different types of classification of trucks. So basically some trucks are permitted on the highways, but some trucks are not permitted on the public highways. Okay. So those which are not permitted on the public highways, we call it as off highway truck. Why they are not permitted? Because their weight, width and height are beyond the limitations which is permissible for the public highway. These are very huge trucks whose weight, width and height are too high. So that prevents its operation on the public highways. But obviously the advantage will be it can handle huge capacity. It can carry huge payload up to several hundred tons. The productivity of these trucks is going to be very high. So very commonly you can see these trucks in quarry. So that is why it is also called as a quarry truck. So these trucks are very huge in size, as I mentioned just now. So commonly you can find it in the quarry. I will show you the pictures later. So based on the method of dumping, okay, you can classify the truck into rear dump, bottom dump and side dump. Some trucks can dump the material at the rear end, some can dump the material through opening at the bottom, okay. Some can dump the material through the sides, okay. So depending upon that you can classify. Then depending upon the type of frame, as we discussed for the earlier missions also, here also we have rigid frame and articulated frame, and based upon the type of engine, either it can be gasoline or diesel based engine, but more commonly you can see that most of the trucks are diesel based engines. Then based upon the configuration of drive, okay, this also we have discussed earlier, like how many axles are powered, okay, and the corresponding wheels will be driving wheels, okay. So based upon how many wheels are driving, you can call it as 2-wheel drive, 4-wheel drive or 6-wheel drive, and depending upon the number of wheels and number of axles in the truck also you can classify, and depending upon the capacity of the truck, that is the capacity of the dump body, you can classify the truck, okay. So there are different means by which you can classify the truck. So this is the picture of the off highway quarry truck. As I told you, it is commonly used in quarry. It is not permitted on public highways because its size and weight is greater, okay, than the limitations allowed for the public highways. And one thing you can note that is it won't have a tailgate, okay, it won't have a tailgate. So that is why you can see that the body floor will be sloping upward. You can see it is sloping upward. This kind of arrangement facilitates easy loading of the truck with the loader, okay. So that is why it has this shape. So the next type is based on the frame. As we mentioned earlier, we have rigid frame and articulated frame. Basically articulated frame means there will be a pivot joint. So the machine will be hinged between the front part and rear part. That permits the articulation. It will have a better turning ability when compared to the rigid frame. So you have an articulated joint and an oscillating ring between the tractor and the dump body. So this is the dump body. So between the tractor and the dump body you have the articulated joint. So that will facilitate better articulation. So this is commonly used for poor underfoot conditions. So poor underfoot conditions in the sense the terrain is very bad and you have to climb steeper grades. Climb steeper grades. In that case, you have to go for this articulated truck. For tough conditions, if the machine has to climb steeper grade, or the terrain is too, it's clay area, okay, so which is not possible for a rigid frame to maneuver. In that case, you can go for the articulated trucks. They are basically designed for tough underfoot conditions. So they can climb steeper grades up to 35%, while the rigid frame is commonly used for only up to 10% slope. I am talking about the slope. But another limitation of this articulated truck is it is designed for poor underfoot conditions. Okay, so these trucks will have a limitation on its capacity and the speed. So its capacity as well as the speed will be lesser than the rigid frame truck. Okay, so depending upon your requirement, whether you can go for rigid frame or articulated truck. And also in confined areas, it is easy to work with this machine, which has a better turning ability. So based upon your requirement, you have to make the selection, but obviously articulated trucks are costlier when compared to rigid frame. So but you have to justify the cost based upon the application. And the next one is your highway rear dump truck. Okay, so you can see the picture, the material is being dumped through the tailgate in the rear end. So you can see the machine will be having a hydraulic jack system. With that, you can lift the dump body and dump the material at the end. So this is the one which is commonly seen. The commonly used one is rear dump truck. But if you look into the dump time, so basically when you go for rear dumping, so it takes little bit more time. This is because since you are dumping at the rear end, you have to correctly locate the location where you have to dump it. Sometimes you have to travel some back distance to exactly locate the place and then dump it. So this may increase the dump time. So for the rear dump mechanism, the dump time is slightly higher. Obviously it depends upon your type of material also. Some material may be easily flowing, in that case dumping will be relatively easier. It also depends upon the capacity of your truck. Okay, capacity of your truck. Your truck capacity, the type of material, all these things will influence the dump time. But basically rear dumping takes more time because you have to exactly locate the location, and then you may have to even travel in a backward direction to locate that location, and then you have to dump it. Okay. Yeah, this video shows you how the rear dump truck unloads the material. Okay, you can see that with the help of this hydraulic jack system. Okay, so the dump body is lifted. Okay, so this is lifting it. Okay, you can see that. Okay, it's lifting the dump body, and the material can be unloaded through the tailgate. So the next is about the bottom dump trailers. So here you can see that dumping will be from the bottom opening. So you have a facility to unload the material to the bottom opening. So when compared to rear dumping, this bottom dumping takes relatively lesser time. So this is because basically we go for these trailers, okay, these bottom dump trailers, when you have to dump the material over a large area. You have to dump it and as well as spread it. Actually the machine will be moving and dumping together. The machine will be traveling and dumping together. Okay, both the operations will be done in one stage. Okay, so the machine will keep on moving as well as it will be keep on dumping the material to the bottom end. So for that you need a larger dumping area, larger dumping site. You need a larger dumping site so that this trailer can easily deposit the material in windrows. They call it as windrows. So you can deposit the material in layers uniformly with this bottom dump trailers. Wherever you want to dump the material over a larger area and spread it uniformly and spread it in layers, then you can go for this bottom dump trailer. Since it is moving as well as dumping, you can see that the dumping time is relatively lesser when compared to the rear dumping trucks. But it has some certain conditions, like as I told you, the material should be free flowing in nature for the bottom dump, like your loose dry earth or sand or gravel. Okay, it should be loose material and it should not be large rock. So that can be handled with the bottom dump trailer. So the material should be free flowing in nature and it should be unrestricted dump site. That means we need a larger dumping site where you can uniformly travel and deposit the material in windrows. So wherever you want to spread the material uniformly, this will be the right choice. Your bottom dump will be a right choice. but it has its own limitation. It cannot climb steeper grades. These kind of trailers cannot climb steeper grades. So now let us look into the production cycle of the truck. Okay, we have discussed so far about the different types of trucks. Okay, now let us move on to what is the production cycle of truck and what are all the different components of the production cycle. So the first thing is your truck should spot the loader. So the truck is helping the loader. The loader should be spotted by the truck. So that spotting time is also included. Then the loader will be loading the truck, that is loading time. Then your the truck will be traveling with the load, that is hauling. Then at the required dumping site it has to dump the material. Then it will be returning in the empty condition, get ready for the next cycle. So all these things makes up the one production cycle of the truck. So as we discussed earlier, some are fixed and some are variable. Some of the components are fixed and some are variable. So what comes under the fixed time? So under fixed time, your spotting of your loader, loading the truck. Okay, obviously it depends upon the size of the truck and also it depends upon the material. Some material are easy to load. Dry earth, your sand and gravel are easy to load. Okay, but blasted rocks, okay, clayey material are difficult to load. Okay, so all these things will affect the loading time. Then whatever maneuvering, changing gears and other things, okay, turning. Then dumping also comes under the fixed time. So as I told you, dumping will depend upon the type of material. Some material can easily flow out, there the dumping time will be less. Then it also depends upon the mode of dumping, in the sense whether you go for rear dumping or you go for bottom dumping or you go for side dumping. So all these things are going to affect your dumping time. But all these things makes up your fixed time, because these are not going to vary with your haul distance. Then the variable time, that is going to depend upon your haul distance, your haul time and the return time, that depends upon your distance as well as the speed. Speed you can get it from the performance chart of the machine. So if you know the weight, if you know the resistances, that is the rolling resistance in your project site and the grade resistance in your project site, if you know these input data, you can find the speed of the machine. So once you know the speed and once you know the distance, I can calculate the variable time. So now let us see how to estimate the productivity of the truck. To estimate the productivity of the truck, okay, these are the steps to be followed. First, I need to find what is the number of bucket loads needed to fill the truck. How many bucket loads are needed to fill the truck? That depends upon the capacity of your truck and the capacity of your bucket of the loader. Okay. So as I told you, these are interdependent machines. Okay, we should go for compatible capacities. That means you should not go for the small truck and a bigger loader or a bigger truck and a smaller loader. In both the cases, your cycle time will be longer. Okay, there will be unnecessary wastage of time. Okay, so that is why you need to balance the capacity of the truck and the loader or the excavator. So as we mentioned earlier, it's based on the studies, they have found out the truck capacity should be at least 4 to 5 times the bucket capacity. Okay, use trucks having 4 to 5 times the capacity of the excavator bucket. So this is the ideal case. So this will give you the maximum productivity. So match the truck and the excavator capacity. Okay, that will result in maximum loading efficiency and reduced total cost, because your cycle time will be reduced, your productivity will increase, so your unit production cost will reduce. Okay. So that is why we have to match the size of the interdependent machines. Okay. Now let us determine how many number of bucket loads are needed to fill a truck. That depends upon the truck capacity and the bucket capacity. Divide truck capacity by bucket capacity, you will get the number of the bucket loads needed to fill the truck. This is the balanced number. Hopefully you should get between 4 to 5 for the ideal case. So if you get a whole number, it is fine. You can either go for the 4 buckets or 5 buckets. But if you are getting some decimal numbers, say 4.2, in that case you have to round the bucket load. Either I should round it to 4 or I should round it to 5. But basically when it is less than 4.5, we round it to 4. But if it is greater than 4.5, in that case it is better to work out the economics of both the cases. That if I go for 4 bucket loads, what will be the unit production cost? If I go for 5 bucket loads, what will be the unit production cost. It is always better to work out the economics of both the cases and make the choice. Now, let us see the cases like one thing is, say for example, if I am going to round the bucket load to the lower number, say I got a decimal number, okay, and I am rounding it to lower number. So, I got 4.2 and I am rounding it to 4 buckets. In that case, how to work out the truck load and the load time, that is what we are going to see now. How to estimate the load time and the truck load volume when the number of bucket loads are assumed to be lesser than the balance load. If the number of bucket loads rounded to next lower integer lower than the balance number of loads, then what will be the load time? Load time is nothing but your number of your bucket loads, that is the number of cycles of the bucket loads multiplied by the bucket cycle time. Okay, what is the per cycle bucket cycle time? So, number of bucket loads multiplied by the bucket cycle time will give you the loading time. Okay, loading time for your truck. Now, how to find the truck load? In this case, since the number of bucket loads is lesser, here we have taken number of bucket loads lesser than the balanced number of loads needed to fill the truck. So, obviously, we are not going to fill the truck to its full capacity. The truck will be short load, truck load will be short. So, sometimes we prefer for short load. Say for example, when you are climbing steeper grades, we do not prefer loading the truck to its fullest capacity, we prefer short loads. So, in this case, since the number of bucket loads is lesser than the balanced number of bucket loads, it is called as short load. So, the truck load is not equal to the truck full capacity. Here, how to calculate the truck load? It is nothing but number of your bucket loads multiplied by the bucket volume. Number of bucket loads multiplied by the bucket volume will give you the truck load, and this is not going to be equal to the full capacity of your truck, as you know. Now, the next case is, say the number of bucket loads which we are going to adopt is greater than the balanced number of loads. So, now we have rounded it to the higher end. Say instead of I got 4.2 and I am rounding it to 5. Okay, say for example, I am rounding it to 5. In this case, it means I am trying to load the truck beyond its capacity. So, obviously, there will be spillage of material. So, if number of bucket loads rounded to next higher integer higher than the balanced number of loads, either the excess material will spill off the truck or some portion of material will remain in the bucket of excavator itself. So, either way it can happen, but one thing you should know that what you can load only to the truck capacity, we cannot load beyond that, excess material will definitely spill off. So, here you have to take the truck load is full and it will be equal to the truck volumetric capacity. Your truck load is full here and it will be equal to the truck volumetric capacity. You should not take it as the number of bucket loads multiplied by the bucket volume as you did for earlier. Okay, number of bucket loads by bucket volume. Okay, you are not going to follow that earlier formula. This way you should not calculate for this, because here the number of bucket loads are more than the balanced number of loads. But even though it is more than the balanced number of loads, I cannot load it beyond the capacity of the truck. Truck maximum capacity will be the limiting capacity. So, in this case you should not go by this. Okay, the truck load will be equal to truck volumetric capacity only. You have to follow that. But the loading time will be number of bucket loads multiplied by the bucket cycle time. Okay, another important thing you have to keep in mind is, for any machine, whatever may be the machine, we have discussed about different types of machine. So far, all the machines we are concerned about the safe gravimetric capacity of the machine. For every machine, what is the safe operating load in terms of weight is given by the manufacturer. So, that we call it as a gravimetric capacity. So, only that capacity your machine can take. Okay, the structural frame of the machine is designed to handle that particular load only. So, we are not supposed to load the machine beyond the gravimetric capacity. So, since the density of material can vary from case to case, it is always advisable to check whether the load weight is within the safe gravimetric capacity. Check the load weight against the gravimetric capacity of the truck. How to check that? For that you need to know what is the unit weight of your material. If you know the density of your material, you can multiply it by the volumetric load. You will get the actual weight of material in the truck. You will get the truck load. That should be within the rated gravimetric capacity of the machine given by the manufacturer. Check. Truck load is less than rated gravimetric payload. See, many times you can see that people will put these side boards, and in the trucks commonly you can see they put the side boards and try to increase the volume of the truck. If the material which you are going to handle is less denser, in that case it won't create much problem. You have to check whether the loaded weight in the truck is within the gravimetric capacity. But if the material is going to be denser, like wet sand or other denser material, what happens is there are more chances that your machine may be overloaded. That means the weight of material in the truck will be above the safe gravimetric capacity defined by the manufacturer. In that case, it will result in lot of wear and tear to the machine. Okay? So, particularly your tires will flex and it will result in abusing of tires. Okay? So, you know that for most of the machines, the tire cost amounts to 35% of the truck operating cost. Okay? So, if you overload the machine, it will result in abusing of tires and it will increase the tire cost significantly. So, this thing you should keep in mind that, like, by keeping side boards and by keeping overloading the trucks, though you are able to increase the productivity for a shorter time, those benefits will be only for the shorter time. This is because if you keep on overloading your truck, it will result in premature aging of the truck and it will result in huge loss for you. It will result in yearly replacement of your truck. Okay? So, you have to replace the truck with a new truck. That will result in huge ownership cost for you. Okay? So, that is why you should not overload the truck. So, next is about the dumping time. Okay? So, as we discussed earlier, the dumping time will depend upon the type of hauling unit, whether it is going to be rear dump or it is going to be bottom dump, okay, or side dump. Accordingly, the dump time will vary. Whether the material is easy flowing material or sticky material, rock, okay, blasted rock, okay, all these things will affect your dumping time. And the congestion in the dumping area, you know that in the construction site, so many equipment will be working parallel. Say for example, in the dumping site, there may be bulldozers and graders leveling. So, in that case, there may be possibilities of lot of congestion in the dump area. Then your machine may have to wait, so till it to get its chance for unloading or dumping. So, the congestion in the dump area, all these things will affect your dump time. So, that is why these values are taken from the textbook by Purify et al. So, they have given you the time needed for bottom dump truck and end dump truck. End dump is nothing but your rear dump. So, for different types of conditions, say they have classified the condition to favorable, unfavorable. Favorable in the sense, favorable condition means say easy flowing material and the congestion in the dump site is less. So, all these are favorable conditions. Okay. Unfavorable conditions means the material is a sticky material or rock, as I told you, okay, which is unfavorable. So, in that case, and there is more congestion in your dump site, so machine has to wait. That is unfavorable condition. So, they have given you the time, approximate estimate of time for favorable and unfavorable condition. So, you can compare the bottom dump and rear dump. You can find that if the conditions are favorable, the bottom dump time is very much less when compared to the rear dump. Okay, that is what I told you earlier also. When compared to rear dumping, your bottom dump time will be relatively lesser, provided the conditions are favorable. But under unfavorable conditions, you can see that both are comparable only, bottom dumping and rear dumping. So, if the conditions are favorable, it is preferable to go for the choice of bottom dump, so that you can have a reduced cycle time and increase productivity. Now, next is about the haul time. Haul time, it depends upon your haul distance. It depends upon your haul distance and the speed. Speed you can get it from the performance chart. So, to use the performance chart, you need to know what is the weight of the machine, and also you need to know what are all the resistances in your project site. So, the rolling resistance and the grade resistance. If you know all this input data, you can find the speed from the performance chart. So, determine the truck speed from the truck manufacturer performance chart. If you know, for that you need to know the weight of the machine and the resistances in your project site. So, once you know the speed and the distance, I can calculate the halt time. The return time, the same way, use the truck manufacturer performance chart, but here the truck will be in the unloaded condition, empty weight, and consider the resistances also. So, you know the distance and speed, I can calculate the return time. Obviously, the return speed will be more, so the return time will be less as the truck is in the empty condition. Now, let us see how to balance the interdependent machines, trucks and the excavators. I hope you remember earlier we have discussed how to balance the interdependent machines, your scraper and the pusher. Okay, in a similar manner, we are going to discuss how to balance the number of trucks and the excavator. So, balancing is very important. Just now we discussed balancing the capacity of the interdependent machines, very important. So, balancing the capacity of the hauling equipment and the excavator bucket size will result in maximum loading efficiency and reduced total cost. So, that is why I told you, based upon the studies, they have found that the truck capacity should be 4 to 5 times the bucket capacity, 4 to 5 times bucket capacity. Okay, that is what is given. This is a thumb rule. Size of the truck 4 to 5 times the capacity of the truck. Okay, that is the ideal case. So, when they are compatible, you can see that the cycle time will be less. Okay, both will be working at maximum production. Now, let us find what is the balanced number of trucks. So, how many trucks are going to be served by one excavator? That is what we are going to find. So, that depends upon the cycle time of your truck and the cycle time of your excavator. Okay. So, divide the truck cycle time by the excavator cycle time, you will get the balanced number of trucks. So, the balanced number indicates a particular number at which both the machines are working at same production level. They will give you the maximum productivity, there will not be much waiting time. So, the cycle time will be less, the productivity will be maximum. Okay. It is preferable to go by the balanced number. Okay. But more often you can see that you may not get a whole number. Say for example, I am getting the balanced number, say 7.4, whether I should round it to 7 or I should round it to 8 trucks. We have to decide. How to decide that? We have to work out the economics. If I go for 7 trucks for one loader or one excavator, if I go for 8 trucks for one excavator, what is the unit production cost associated with that? You consider both the cases and then make a decision. That will be more logical. Now, let us consider the case, say the number of trucks lower than the balanced number. Say I am going to round it to lower number, say I got 7.4, now I am going to round it to 7. When I round it to lower than the balanced number, that means trucks are less than what is needed. So, trucks are more critical for the production. So, here the loader will have the idle time, loader will be waiting for the truck. Okay. So, truck cycle time will control the productivity of this team. Okay. So, the truck productivity will be controlling. Okay. So, production, how to estimate the production in this case? Truck load multiplied by number of trucks divided by the truck cycle time. Truck load multiplied by number of trucks divided by the truck cycle time. So, here truck cycle time I have taken in minutes. So, I am converting it into hour because I need the productivity in loose cubic meter per hour. So, I am just multiplying by 60 minutes. In the case when I round it to the number greater than the balanced number. So, instead of rounding it to 7, I am rounding it to 8. My balanced number is 7.4, I am rounding it to higher end 8. In this case, number of trucks are greater than the balanced number. So, the trucks will have the idle time. Truck will be waiting for the loader. Loader will be critical here. Okay. Beyond the balanced number, you can see that the productivity will be controlled by the loader cycle time. Okay. Unless the loader is available, though the trucks are more in number, they cannot do the job. Okay. So, the production is going to be controlled by loader cycle time or excavator, whatever, excavator cycle time. Now, how to estimate the productivity? Truck load divided by the excavator cycle time. Okay, it's in minutes. So converting it to hour, I need to multiply by 60 minutes. This will give the production of the system when the number of trucks are greater than the balance number. If we round it to number greater than the balance number. But very commonly you can see that people prefer to round it to lower than balance number. So one reason is basically when it is lower than the balance number, you can engage the excavator or the loader to dress the loading site, and it will get ready for the next truck. And people also do not prefer working with loader continuously, because if the loader or the excavator works continuously and if it breaks down, it will severely affect your entire system. Say for example, you have only one excavator, okay, and if the excavator breaks down, that will hamper your project seriously. But the trucks are more in number. Even if a truck breaks down, if one truck breaks down, it will affect the production, but that won't be as serious as the breakdown of a loader or the excavator. That you have to always keep in mind. That's why routine maintenance of the loader or the excavator is very important, okay, for the continuous running of the system. Okay, that's why people always prefer rounding it to lower number. But the logical way is to work out the economics of both the cases, okay, and then take a decision. That will be more logical. Okay. Now let us work out a problem on balancing the interdependent machines. Okay. So here a loader is operating at 90 meter cube per hour and it has a 2.2 heap capacity bucket and operates on 1.1 minute load cycle. The cycle time of the bucket is given as 1.1 minute. Cycle time per cycle, it is 1.1 minute for the bucket of the loader. Truck will be loaded by the loader and the truck's capacity is 10.3 meter cube capacity and 34 minute dump plus haul plus return time. Other than loading, what is the time needed for dumping, hauling and returning is given directly to you. Okay, if it is not given, then you have to go for the performance chart to find out the haul time and the return time, and you can go by the manufacturer's data for the dump time. Truck fill factor is estimated at 100%. So based upon the filling ability of the material, it is given as 100% for truck, but for the bucket, it is given as 90% based upon the filling ability of the material. So whatever the rated heap capacity given by the manufacturer, I have to adjust with the fill factor. Say for the loader bucket, it is 2.2 meter cube. This is the rated heaped capacity given by the manufacturer. Adjust it with the bucket fill factor 90%, 0.9. Similarly, for the truck, it is 10.3 meter cube. Here the filling factor is 1. That's it. So you have to get the realistic estimate of the load volume by adjusting the rated heaped volume with the bucket fill factor or the truck fill factors accordingly. The efficiency estimate is 50 minutes per hour. Okay, the job efficiency is given. That means the machine is working for 50 minutes in an hour. Find out the optimum number of trucks required for each loader. So we are going to find the balance number at which the productivity is going to be optimum. Also, calculate the unit cost of production using the following hourly rates. Okay, the hourly rate or the hourly cost associated with the loader, including the operator cost, is given as rupees 2700 per hour, and for the truck it is given as rupees 1650 per hour. Now let us work out the solution. The first step will be to find the balanced number of the bucket loads needed to fill the truck. How will you find the balanced number of bucket loads needed to fill the truck? It depends upon your truck capacity by your bucket capacity. So what is your truck capacity? It was given as 10.3 meter cube. You adjust it with the fill factor, truck fill factor is given as 1. Similarly, the bucket capacity is given to you as 2.2 meter cube. You adjust it with the fill factor, it is nothing but 0.9. So you will get the answer as 5.2. Okay, you can see here 5.2 is the balanced number of bucket loads. So we did not get a whole number. Now I have to round it. In this case, it is lesser than 5.5. So I can round it to 5 bucket loads. But if it is going to be 5.5 or greater than that, it is preferable to work out the economics of both the cases as I mentioned earlier. If with 5 buckets, what will be the 5 bucket load, what will be the unit production cost? With 6 bucket loads, what will be the unit production cost? You are supposed to work it out to make a right decision. Okay, but in this case it is lesser, so I am rounding it to lower number, 5 buckets. So obviously, I am going to load the truck not to its fullest capacity. The truck load is short load, here short load. Okay. Now how to find the loader cycle time to fill the truck? It depends upon the number of the bucket loads, that is 5 multiplied by the cycle time of the bucket per cycle. It is given as 1.1. So 1.1 into 5 gives you 5.5 minutes as the loader cycle time to fill the truck, okay, to load the truck. Now what will be the truck cycle time? Truck cycle time is nothing but loading plus hauling plus dumping plus returning. So this value is completely given to you in the problem as 34 minutes, haul plus dump plus return. Loading time you have just now estimated 5.5 minutes. So 5.5 plus 34 gives you 39.5 minutes as a truck cycle time. Now I need to find the truck payload. So here you know that I am not going to load the truck to its full capacity because I am rounding the bucket loads to lesser than the balance number. So the truck payload will be equal to your number of buckets into bucket capacity, rated bucket capacity multiplied by the fill factor. So number of buckets, balance number we have taken is 5, bucket capacity is given to you as 2.2 meter cube, fill factor is 0.9. If you multiply, you will get the answer as 9.9 meter cube. Okay, that is what is given here, 9.9 meter cube. Now you find the truck production. Okay, you can easily find the truck production. So what is the volume of truck you are going to load in this case? 9.9 meter cube. 9.9 meter cube. You are also supposed to check whether the truck payload is within the gravimetric capacity. If say gravimetric capacity is given by the manufacturer, you have to check, okay, whether the weight of the load of material in the truck is within the gravimetric capacity. For that you need the input data of the density of the material also. Now let us calculate the truck production. Truck production is nothing but your truck capacity, I mean the truck payload, okay, truck payload, here it is not full load, it is short load, 9.9 meter cube, okay, we have derived here, divided by the truck cycle time is 39.5 minute. Since it is in minute, I need to convert it into hours, so let me divide it by 60. And another important thing you should never forget is job efficiency. The machine is going to work for 50 minutes an hour, 50 by 60. So this will give me the answer as 12.53 meter cube per hour. So this is how you have to estimate the truck productivity. Now let us find the balance number of trucks needed for one loader. So that depends upon here the balance number of trucks per loader going to be served by one loader is equal to your truck cycle time divided by loader cycle time. So you have estimated the truck cycle time earlier, so you have estimated it as 39.5. Okay, the truck cycle time is 39.5 and the loader cycle time is 5.5. You have calculated the loader cycle time as 5.5. So this gives me the balance number as 7.18. Here also I did not get the whole number, so I have to do the rounding. Either I can round it to 7 or I can round it to 8. So, but the logical thing is you have to work out the economics of both the cases and then take the decision. So here I am going to work out the economics of both the cases. So just to give you a better explanation, I am just working out what will be the economics when I go for different number of trucks. Say if I go for 5 number of trucks, 6, 7, 8 and 9, okay, how the productivity will vary, how the unit production cost will vary. We will work it out and see, so that we will get a clear picture on what is the effect of number of trucks and what is the effect of increasing the number of trucks beyond the balance number on the unit production cost. Okay. So, we will do an in-depth analysis by working out for all the number of trucks. So, basically how to estimate the job production? So, it is nothing but your single truck productivity multiplied by number of trucks, that will give you the job production. So, provided the number of trucks are lesser than the balance number, in that case you can calculate by that, because when the trucks are lesser than the balance number or equal to balance number, okay, your truck cycle time will govern the productivity. Okay. But when the number of trucks are, this is your balance number, say 7. So, actual balance number is 7.18. So, when the number of trucks are lesser than the balance number, say 5 trucks, 5 into productivity of your truck, individual truck productivity is 12.53 meter cube per hour. So, that gives me the value as 62.65 meter cube per hour. Okay, this is what you got. Similarly, when the trucks number of trucks is 6 into 12.53 meter cube per hour, that will give me the answer as 75.18. Okay. When the number of trucks equal to 7 into 12.53 gives me the productivity as 87.71 meter cube per hour. When the number of trucks is 8 into 12.53, I am getting the value as 100.24 meter cube per hour. Okay. But I cannot go by this productivity. Okay. This is because when the trucks are lesser than the balance number, equal to balance number, your truck will be controlling the productivity of the system. Beyond the balance number, okay, so you can see that number of trucks are more. Okay. So, the truck will be waiting for the loader. Unless the loader is available, your truck cannot do the job. So, the productivity here will be controlled by your loader. So, beyond the balance number, you can see that you cannot go beyond the productivity of the loader, because the loader cycle time will control the productivity of the system. For cases above the balance number, you cannot go beyond the productivity of the loader beyond the balance number. Though the number of trucks are more, you have 8 trucks, you have 9 trucks, but the trucks will be simply waiting for the loader only. That is why it is not preferable to increase the number of trucks beyond the balance number, because the trucks will be just waiting for the loader. Okay. So, we cannot go beyond the productivity of the loader. So, unnecessarily it will increase your production cost because of the increase in the cost of trucks. Even though I get the productivity as 100.24 if I go for 8 trucks, but the actual productivity will be only 90 meter cube per hour, because I cannot go beyond the productivity of the loader. Loader will be controlling beyond the balance number. This picture, the balance point graph, clearly illustrates what is the significance of the balance point. So, as you keep increasing your truck number, you can see that the productivity is significantly increasing. At the balance point, you can see that the productivity of your truck and the productivity of the loader will be same. Okay, loader productivity is 90, right? The loader productivity is 90 meter cube per hour. At the balance point, both the machines are working at same productivity. But beyond the balance point, even if you increase your trucks, you cannot get this productivity. You cannot go beyond the loader productivity level. That will be the limiting value, because you have only one loader. Okay. Whether you have 8 trucks or 9 trucks or 10 trucks, all these trucks are going to just wait for the loader. Okay. So, it is not advisable to increase the number of trucks beyond the balance number, because there is only one loader here that will be controlling the productivity of the system. Now, let us work out the economics, because most of the decisions are based upon the economics. People are more concerned about the unit production cost associated with the machine. So, whichever combination gives you lesser unit production cost, we will advise that combination. Okay. So, that is how we are supposed to follow. Okay. The unit cost here will be calculated for the different combinations. Okay. So, how to calculate the total unit cost for the truck loader combination? I need the input data. So, the input data is given to you. What is the cost associated with the loader and the truck? Okay. The hourly cost data is already given to you, rupees 2700 per hour for the loader and rupees 1650 per hour for the truck. Now, let us estimate the total the unit cost for the truck loader combinations for different number of trucks. Okay. Say for 5 number of trucks, how will you calculate the total cost? Total cost is nothing but 5 into what is the hourly cost of truck, 1650, plus there is only one loader, okay, 1 multiplied by 2700. So this gives me the cost is 10,950 rupees. This will be the cost associated with the 5 trucks. Similarly, for the 6 trucks, 6 into 1650 plus 1 into 2700. So this gives me the cost is rupees 12,600. You can get this. Similarly, for the 7 trucks, 7 into 1650, okay, plus 2700. This gives me the cost as rupees 14,250 per hour. Okay, like this you keep calculating for 8 trucks and 9 trucks, you can calculate the cost, total cost per hour. Now your productivity, already you have estimated the productivity in the earlier table, 62.65, 75.18, 87.71, but you have to note that beyond the balance number, the productivity will be only 90. I cannot go beyond 90 because beyond the balance number, the productivity is controlled by loader whose productivity is 90 meter cube per hour. Okay. So that is why you can see the productivity is only 90 beyond the balance number. Okay. Now you have to calculate the unit cost of production. How to estimate the unit cost of production? Unit cost of production is nothing but cost per hour divided by productivity per hour. So for the number of trucks 5. So for 5 trucks, what is the total cost? 10,950 divided by productivity is 62.65. Okay. So this gives me the answer is rupees 174.78, okay, per meter cube. This is a unit production cost associated with 5 trucks. Similarly, for 6 trucks you have to calculate. 6 trucks, it is nothing but 12,600 divided by 75.18. Okay, 75.18 gives me the value is 167.60. You can see here. Similarly, you find the unit production cost by dividing total cost by productivity, you will get the unit production cost. For all the cases, you can just find it. Okay, for all the cases, 5 trucks, 6, 7, 8 and 9. Okay, so one important thing you have to note here is, okay, when the number of trucks is 5, though the total cost is less in this case, but the productivity is also less. That is why you can see that the unit cost is high. But as your number of truck increases, you can see that the productivity increases significantly. That is why your unit cost of production reduces. Okay, it is reducing. But beyond the balance number, okay, beyond the balance number 7, when I try to increase the number of trucks, there is no increase in productivity. Because the productivity is limited by loader, I cannot go beyond 90, but your truck cost is unnecessarily increasing. Okay. So because of that, I can see that the unit cost increases significantly, unit production cost increases significantly. That is why it is not advisable to go beyond the balance number. Okay. So graphically you can see this. Okay. So when the number of trucks are less, your unit production cost is less. When the number of trucks is 5, when the number of trucks is less, the unit production cost is higher than the optimum value. You can see the optimum value for the number of trucks 7, okay, the unit production cost is 162.47. Okay. But when you go for 5 trucks, you can see that the unit production cost is higher than the optimum value. Why it is higher than the optimum value? Because here productivity is less in this case. But when you increase the number of trucks, you can see that the productivity will increase significantly. So your unit production cost keep reducing. Okay, and when you reach the balanced number, you can see that you can have the minimum unit production cost. But when you try to increase number of trucks beyond the balanced number, what is happening? There is no increase in productivity. Beyond the balanced number, the productivity is limited by the loader. So I cannot go beyond 90 meter cube per hour. Okay, that was the productivity of the loader. Okay, I cannot go beyond 90 meter cube per hour. But the cost of the truck is increasing. That is why you can see that unit production cost significantly increases. So it is always preferable to go by the balanced number. But in this case, our balanced number was 7.18. Okay, it was 7.18. So whether to round it to lower number or round it to higher number, whether I should go for 7 or whether I should go for 8. If I go for 7, my unit production cost is 162.47. If I go for 8 trucks, my unit production cost is 176.67. So it is preferable to round it to the lower number. Rounding to lower number is preferable. As I told you, this is what is commonly followed. When you round it to lower number, you can you can give some break time for your loader. Okay, that is also one way good. The loader will help you in clearing dressing the site, as I told you, the site, as well as there will be some break time for the loader, and it will get ready to load the next truck. That is why the people always prefer to round it to lower number, but anyway, it is always preferable to work out the economics of both the cases. I have worked out and showed you. You can see that for lower number of trucks, the unit production cost is very less. Okay, for 7. In this case, for when you go for 8, okay, there is no significant increase in productivity. That is why you can see that the unit production cost increases significantly. Okay. So whether you go for 8 trucks or 9 trucks, there won't be increase in productivity. There will be just increase in the truck cost. That is the reason it is significantly increasing. So we have come to the end of this lecture. Let me now summarize. Okay, we have discussed about the different types of trucks, and I told you the importance of checking the payload. Okay, the weight of load inside the truck against the rated gravimetric capacity. You should never overload the machine, which will result in premature aging of your truck as well as the tires. Okay, and dumping time, when you calculate, you should know that it depends upon the mode of dumping, whether you are going for rear dump trucks or bottom dump trucks, and the material type, easy flowing or tough material, and also it depends upon the congestion in the dump area. All these things are going to affect your dumping time. So when you work in a team with machines, so basically all the interdependent machines should be balanced in their size as well as it should be balanced in number. Excavator and truck should be of compatible capacities. Okay, based on studies they found that truck capacity should be 4 to 5 times the bucket capacity of the excavator. That is the ideal case. So then the number of machines also to be balanced. At the balanced number of machines, you can see that both the loading unit and the hauling unit will operate at the same production level. Okay, you will get your maximum efficiency at the balanced number. The waiting time will be minimum. And always, whether you are going to round it to a lower number or round it to the higher number, work out the economics, work out the unit production cost associated with both the cases, and then evaluate the balanced number and decide your selection. Okay, estimation of job cost, I have done it already by evaluating the equipment balance. So these are the references which I have referred for this lecture. You can try to procure these textbooks for preparation. In the next lecture, we will be discussing about the piles and the pile driving methods. Okay, thank you.